Apply the force horizontally, so we can try to make it stay there without sliding down. Okay. So what happens is that you have some weight, this object, W of course equals to mg, and you have some normal force, and then I'm going to apply a horizontal force to overcome the sliding tendency of this object. By the way, I didn't mention if the force should be applied to the left or to the right. Okay? Should I give you this explicitly, or you can determine it by yourself? Should this force be pointing to the right or left?
Right. Pointing to the right.
This way or this way? Okay? So the force has to be applied to that direction. Okay? Otherwise, you can just, if you apply to this direction, you are going to make the sliding down even faster. Okay? So that's something you have to be able to analyze from the physical situation. This horizontal force, even it's not told, it has to be to that direction. Okay? And we want to find how large the force it is. Okay. And the idea, of course, is that if you apply a very small force, so the object will still be sliding down. Okay. If you apply a too large force, you are going to push the object upwards. So there is some balance point where with that magnitude, the force will exactly cancel the other forces to make it stay there. Okay. So we want to determine how to apply this balance argument to find the force. And our idea is to, again, for all the problems, we always follow standard procedure, okay, and then figure out, after we write down the Newton's second law, can we solve for the unknown quantities? Okay, so for every problem, you have to write down the Newton's second law. And before you can write down the Newton's second law along x direction and y direction, you have to do the decomposition, right? To get all the x and the y components. And before you can do the decomposition, you have to choose something. You remember what you need to choose? The coordinates, okay? So for a inclined plane problem, last time we had a choice of this kind of coordinates, right? Okay, we said in that case it's better than the normal coordinates. And for this problem, should we choose this kind of coordinates? No? Okay. In fact, for this problem, it's better to make just the normal coordinates. Positive x, positive y, like this. Okay? So, then make sure you know you should choose this instead of this for this particular problem. Okay. And can you help me to give some supporting argument why this is better than that one in this case? Because there are two arguments that support this.
Because two of your components are going down axis.
Okay, first, a better coordinates means you try to make more forces along x and y directions. So then you have less forces need to be decomposed with sine, cosine stuff. So with this kind of choice, you can see F, this unknown force is along x direction, and W is along y direction. So the decomposition will be easier. And you only need to deal cosine and sine stuff for this force. If you make this kind of choice, look at, you have three forces, F, W, and A. If you make this choice, then A is along y direction, but you have to decompose both F and W. Okay? So that's the first argument. Do you have any other argument here? Okay, remember, for our previous problem, you can go to check. One of the important support to choose this kind of coordinates is because the acceleration is like this one, right? So by choosing this kind of coordinates, can simplify your calculation for acceleration A. But in this case, what is the acceleration? You don't even have the acceleration, okay? So of course, this kind of argument will not go to this one. Okay. You just look at the force. Okay. Any question here in the about the choosing coordinates? That's kind of important things. Okay. I found that whenever for the similar situation you have different choices, that always makes some trouble in your test problem. Okay. So when the problem like this, if it's good to use this coordinates and you choose this kind of coordinates, it will make a lot of trouble for you in the test. Okay. So think about so for the problem solving, in reality, you always need to do some choice. Okay. There will always be more than one way to deal with the problem. You have to choose the best way. Okay. And I didn't know if you noticed that in your last test problem, there is a problem. If you made a very good choice, that problem will be super easy. Okay. One of the vector ending problem is actually a one-dimensional problem. So if you already realize that, that problem is super easy. Okay. Now, after we make this choice, of course, I know some of you already realize that because I think one or two students solve the same problem with both ways. Okay. Okay. Now, the next thing we're going to decompose these forces. So F and W will be either Fx, Fy, Wx, and Wy. Let's first write down these things. What is Fx in this coordinate? How to express it? Oh, okay. By the way, what is Fy first?
0.
0. Why is along x direction? It doesn't have any x component. So it doesn't have any y component. Then what is Fx?
It's F, just F.
Okay, remember if another component vanishes, then, okay, this component should be the same as the magnitude of the total force. Okay, that's simply from the combination rule of the vector. Okay. So that's to tell us to calculate F is the same to calculate Fx in our equation. Okay. Now, what is Wx and what is Wy? Positive or negative? Negative mg, okay? And then we have to write down nx and ny. Okay, so this is n. If you decompose it, this is nx and this is ny, okay? So we have to know some angle here, and the geometry, from the geometry, you know if this angle is given theta equals to, what's the angle here?
36.9.
36.9? Okay. So, and then this should be the same angle theta, okay? And if this angle theta is known, how do you express nx and ny? Nx?
That's cosine.
What multiplied by cosine? Sine or cosine?
Wait.
Should be sine,
That's sine.
right?
Yeah.
This is nx, so it's here opposite to the nx. So it should be n multiplied by sine theta, positive or negative? In this coordinate, positive or negative?
That one's negative.
Negative. Okay. How about ny?
That's n cosine theta.
Positive n multiplied by cosine theta. Okay. Now, we can write down the Newton's second law along x direction, y direction. If you combine these x forces together, will give you Fax. So F minus n sine theta equals to Max. And if you combine these three y forces together, will give you May. So you get 0 plus negative mg plus n cosine theta equals to May. In this case, can we simplify ax and ay, the acceleration? What is ax?
0.
What is ay?
0.
Okay, both will be 0. Since the total acceleration is 0, it stays there, no acceleration at all. Okay. And another thing I would like to emphasize again, this kind of simplification condition, you cannot memorize them because that's just case by case. In this case, both ax and ay equals to 0. And in some other cases, you have ax equals to a, ay equals to 0. You remember that? Okay, so all due to the actual motion. Okay, there's nothing to memorize. And then with this, you can simplify the two equations, f minus n sine theta equals to 0. And negative mg plus n cosine theta equals to 0. Okay. So now you can see, we want to calculate, so here m is the given quantity, but what is m here?
10 kilograms.
10. Okay. G is constant, cosine, sine, theta, they are known quantities. So we want to calculate f, right? So we can calculate f from the first equation. But to do that, we have no normal force n first. And n can be calculated from the second equation. Okay. So in this case, the two equations are coupled to each other because n appeared in both equations. So, from equation 2, we can solve for n. N equals to mg divided by cosine theta, right? This is n. And, okay, substitute n into equation 1, then you get f minus n, which is mg divided by cosine theta, multiplied by sine theta equals to 0. So that means f equals to mg multiplied by tangent theta. Sine over cosine equals to tangent. Right? So if you substitute number, you can get something easy. Okay? Any question here?